Hello friends, welcome to aimstoday YouTube channel. In this video, we are going to discuss about IIT-JEE NEET Foundation Chemistry Chemical Bonding chapter. From this, the concept of hybridization hypothesis. The concept of hybridization of atomic orbitals was proposed by Pauling. The shapes of molecules and bond angles can be explained in terms of hybridization. The phenomenon of intermixing of atomic orbitals of the same atom which have nearly same energy to form equal number of new orbitals of equivalent energy is known as hybridization. So, the new orbitals of equivalent energy so formed are called as hybridized orbitals or hybrid orbitals. The resulting hybrid orbitals are equivalent in energy to one another and are oriented so that they can form bonds with other atoms. Hybridization helps to predict the shapes of the molecules. So, rules of hybridization to understand. The orbitals of one and the same atom only participate in the hybridization. Orbitals of the different atoms do not hybridize. That means the orbitals present in the same atom intermix each other to form hybridization. The number of hybrid orbitals formed is equal to the number of atomic orbitals participating in the hybridization. That means how many orbitals are intermixing, the same number of new hybridized orbitals will be formed. A hybrid orbital can have maximum 2 electrons with opposite spins. Hybrid orbitals form only sigma bonds, they do not form pi bonds. The hybrid orbitals are symmetrically arranged around the nucleus of the atom so that they have maximum stability. So, now let us say about different types of hybridization. Based on the types of atomic orbitals involved in intermixing, the hybridization can be classified into different types. They are sp hybridization, sp2 hybridization, sp3 hybridization, sp3d hybridization, and sp3d2 hybridization, and so on. So, in this way, the hybridization can be differed based upon the number of atomic orbitals involved in the intermixing. Now, let's see the first one among them as sp hybridization. The intermixing of one s orbital and one p orbital to give two equivalent hybrid orbitals is known as sp hybridization. The two sp hybrid orbitals have linear shape. In this way, they will be linear one to other and with an angle 180 degrees. Each sp hybrid orbital has 50% s character and 50% p character. Sp hybrid hybridization is also known as diagonal hybridization. Now let us see the examples for the molecules having sp hybridization with the formation of beryllium fluoride. In this beryllium fluoride molecule, the central atom is beryllium. The electron configuration of beryllium atom in its excited state is 1s2, 2s1, 2p1, 2p1. This can be diagrammatically shown like this. Actually, the beryllium configuration is 1s2, 2s2 in its ground state. But in the excited state, that means before bond formation, one electron is excited from 2s to 2px. So, it will be having two unpaired electrons in two orbitals. In excited state beryllium atom, 2s and 2px orbitals intermix each other to give two equivalent sp hybrid orbitals. So, in this way, one s orbital and 2px orbital, which are having two unpaired electrons in each one of them, intermix each other to form two equal energetic sp hybridized orbitals. The electron configuration of fluorine is 1s2, 2s2, 2px2, 2py2, 2pz1. It has one half-filled p orbital, that is 2pz, with one electron it is. The half-filled 2pz orbital of two fluorine atoms overlap with the sp hybridized orbitals of beryllium atom in their axis to form two spp sigma bonds. In this way, already beryllium has a hybridization, sp hybridization with two hybridized orbitals, one with a single electron. The 2pz orbitals of fluorine overlap with these sp hybridized orbitals to form sigma bonds. In that way, beryllium fluoride has two spp sigma bonds. Beryllium fluoride molecule so formed has linear shape. The bond angle in this molecule is 180 degrees. Some other molecules which are having this sp hybridization are C2H, that is acetylene molecule, or ethine, hydrogen cyanide, carbon dioxide, etc. sp2 hybridization. The intermixing of one s orbital and two p orbitals to form three equivalent sp2 hybrid orbitals is known as sp2 hybridization. So here in this sp2 hybridization, one s orbital and two p orbitals intermix each other to form three equal energetic sp2 hybrid orbitals. The three sp2 hybrid orbitals are directed towards the corners of equilateral triangle with an angle of 120 degrees. Each sp2 hybrid orbital has 33.33% s character and 66.66% p character. Now let us see here examples of the molecules having sp2 hybridization with the formation of boron fluoride, or boron trifluoride it is called. In this molecule, the central atom is boron. The electron configuration of boron atom in its excited state is 1s2, 2s1, 2p2. So diagrammatically you can show like this. Boron has general ground configuration of boron is 1s2, 2s2, 2p1 actually. But in the excited state, one electron from 2s it jumps to 2py1. Hence the valence configuration becomes now 2s1, 2px1, 2py1. So in this excited state, 2s orbital and 2p orbitals intermix to give three equivalent sp2 hybridized orbitals. In the formation of boron trifluoride molecule, three sp2 hybrid orbitals of boron overlap with half-filled 2pz orbitals of three fluorine atoms in their axis to give three sp2p sigma bonds. So already here boron has hybridized orbitals, sp2 hybridized orbitals 3. Each hybridized orbital overlaps with 2pz orbital of fluorine atom to form sp2p sigma bonds. 3 sp2p sigma bonds are formed, hence boron trifluoride molecule is formed. This boron trifluoride molecule so formed has a trigonal planar structure with a bond angle 120 degrees. Some other examples of the molecules which are having this sp2 hybridization are C2H4, that means ethene or ethylene, boron trichloride, etc. Now let us say about sp3 hybridization. The intermixing of one s orbital and three p orbitals to give four equivalent sp3 hybridized orbitals is known as sp3 hybridization. So here we can see here. So by intermixing of one s orbital and three p orbitals to give four equal energetic sp3 hybridized orbitals. The sp3 hybridized orbitals are directed towards the four corners of regular tetrahedron. The angle between any two sp3 hybrid orbitals is found to be 109 degrees 28 minutes. Each sp3 hybrid orbital has 25% s character and 75% p character. Now let us see one example for the sp3 hybridization, that is formation of methane molecule. In the methane molecule, the central atom is carbon. The electron configuration of carbon atom in its excited state is 1s2, 2s1, 2p3. So this also you can see diagrammatically like this. General ground configuration of carbon is 1s2, 2s2, 2px1, 2py1. But in the excited state, one electron jumps from 2s to 2pz. So it has 4 orbitals with unpaired electrons. In the excited carbon atom, this 2s orbital and these 3 2p orbitals intermix to give 4 equivalent sp3 hybrid orbitals. In the formation of methane molecule, 4 sp3 hybrid orbitals of carbon overlap with 1s orbital of 4 hydrogens in their axis to give 4 bonds. Methane molecule so formed has tetrahedral shape. The bond angle in CH4 molecule is 109 degrees 28 minutes. Some other molecules having this sp3 hybridization are methane molecule, C2H6, carbon tetrachloride, water, ammonia, etc. These all contain sp3 hybridization on their central atoms. Next, sp3d hybridization. The intermixing of one s orbital, 3 p orbitals and 1 d orbital to give 5 equivalent sp3d hybrid orbitals is known as sp3d hybridization. So in this way you can see here, 1 s orbital, 3 p orbitals and 1 d orbital are intermixing to give 5 equivalent energetic sp3 hybridized orbitals. This hybridization we can find in PCl5 molecule. On the central atom phosphorus, it has its 5 orbitals with single electrons. They are 3s, 3px, 3py, 3pz and 3d. These 5 orbitals have single electrons in excited state. These 5 orbitals overlap, intermix each other to form sp3d hybridization, and hence it is forming PCl5 molecule. sp3d2 hybridization. The intermixing of 1 s orbital, 3 p orbitals and 2 d orbitals to give 6 equivalent sp3d2 hybrid orbitals is known as sp3d2 hybridization. Here you can see 1 s orbital, 3 p orbitals, 2 d orbitals are intermixing to form 6 equal energetic sp3d2 hybrid orbitals. So the best example for the molecule having this sp3d2 hybridization is S6 molecule. That the central atom sulfur has this sp3d2 hybridization. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.